We'll look at the northern hemisphere, so they would be typical for the continental United States. We'll start with the warm fronts. They represent, of course, like all fronts, they represent a transition zone between air masses. And the warm front specifically is a warmer air mass that is replacing a colder air mass. These fronts typically form east of a center of low pressure, where the southerly winds of the lows counterclockwise rotation would push the warmer air northward. Warm fronts generally move from the southwest to the northeast. And as the warm air advances, cold air acts as a gently sloping ramp, and you'll see in the diagram there. This ramp gently uplifts large areas of warmer, less dense air. The slope typically a shallower slope compared to a cold front. And that's why warm fronts will typically be characterized by a larger area of cloud cover and rain, of course. Because the advancing warm air is less dense, of course, it has a difficult time pushing the heavier cold air back. And so that's why warm fronts will move more slowly than a cold front. And, of course, it'll contribute to a longer period of cloudiness and rain showers. Clouds and precipitation from a warm front can extend for hundreds of miles, both in the front and behind the warm front, just because of that gradual slope. As the warm front approaches, you'll typically observe some very high, wispy cirrus clouds. As the front nears, the cloud layer will thicken and the base will drop. So we'll see cirrostratus clouds, altostratus, stratus, and nimbostratus clouds as the front moves towards us. Now, following the passage of a warm front, lower clouds form, and eventually followed by clearing skies. The precipitation associated with a warm front is steady and light to perhaps moderate, not usually severe rain. Due to the slow speed of the front, rain can last several hours or even several days. Warm fronts occasionally, they do produce thunderstorms with more intense rain, of course, that's possible. Warm fronts are characterized by that transition from the southeasterly to southwesterly winds. Unlike cold fronts, winds along the front are generally light and variable. We always have a wind shift when frontal passage. And of course, warm fronts will get, generally the surface temperatures are going to warm, of course, and humidity will increase as well. Barometric pressure will fall as a warm front approaches. Behind the warm front, pressures will stabilize and slowly rise again. Warm fronts are generally characterized again by poor visibility and lower layers of overcast and overcast clouds. So that's the warm front. Cold fronts, we call them cool fronts or cold fronts. Cold should be a relative term, so it may be a drastic drop in temperature. It may be just a moderate change in temperature. But at any rate, when a cold front is forecast for your area, it means that several things are happening prior to the front getting there. The winds will be moving from the south to the southwest. Temperatures ahead of the front being warmer. As the cold front is, as we watch it approach, it will be evident that the temperatures between the start of the front to the rear will change significantly. It'll drop, and the clouds will increase as well, cloud cover. For example, a typical front perhaps would start with a 75 degrees Fahrenheit. At the back of the front, it may be 50 degrees Fahrenheit. Again, that's relative, depending on which kind of air mass is coming. Cold fronts also produce showers, of course, as a high dew point, hazy visibility as well. So there's some similarities between a warm front. As the cold front passes the area, we'll have a drop in temperature, of course, winds building and shifting, rains increase perhaps for a while. A mixture of hail, lightning, and thunder, cumulonimbus clouds are common as the front passes us. Large clouds will extend high into the sky. Hazy visibility in the cloud front will continue and slowly clear as the front passes by. Now, cold fronts commonly have a rapid movement and are connected to severe weather often. For example, thunderstorms, squall lines, multiple thunderstorms, may occur in the presence of a cold front. Cold fronts have extended weather patterns as well. They may often start, at least in Georgia, many of these cold fronts start up in Canada from the Arctic air mass and stretch all the way down through here, even into Florida. But they're easy to detect because of our extensive use of radar and satellite technology. We have plenty of warning when they're going to come. Now, there's a third kind of front, which was a stationary front, and as all fronts, it's a transition zone between two air masses, and in this case, stationary front typically is a transition zone between a warm and a cold front. Two air masses slow as they approach. In this case, stationary fronts are characterized by very little movement. And of course, what we know about warm fronts and cold air mixing with cold air, we have long periods of rain and cloudy skies. Each on either side of the stationary front. If it's humid enough on either side of the front, extreme precipitation and poor visibility is likely during that period. So the stationary front is when a warm front and a cold front just sort of stop, hesitate, very, very little movement, and so there'll be long-term rain usually. The fourth kind is an occluded front, and this is where, and you can see the diagram is probably a better description than I can verbally tell you, but it's warm front. We have two cold air masses, and then an air mass between the two, and the warm air mass gets squeezed between the two, and it no longer touches the surface. It's pushed up aloft. And what do we know about that? When warm, moist air is pushed up higher, the temperature drops and precipitation falls. So in a occluded front, we can also expect rain and cloudy skies. Again, occluded fronts form around two areas of low pressure, stormy weather, typically stormy weather, often heavy precip from cumulonimbus or nimbostratus cloud layers, and strong winds. And the wind after this front passes, which may be slow, it may be fast, when this kind of front passes, there'll be a change in wind, of course, and a temperature change. And those are the two, temperature being the major, but wind direction and temperature changes are how we detect that a front has passed. So those are the four kinds. We have the warm front, the cold front, the stationary front, and the occluded front.